Welcome students to the session of panoramic physics. Students, today our topic is very interesting one. Bar magnet as an equivalent solenoid. बार मैग्नेट सोलेनॉइड की तरह बिहेव करता है. एम्पियर हाइपोथेसिस आपने पढ़ी थी. एम्पियर हाइपोथेसिस इन प्रीवियस चैप्टर इट डील विद द सर्कुलेटिंग करंट. आपने एम्पियर हाइपोथेसिस में देखा था और एम्पियर हाइपोथेसिस ने प्रूव किया था कि सर्कुलेटिंग करंट्स कैन एक्सप्लेन द एंटायर मैग्नेटिक फिनोमिना. यानी एम्पियर हाइपोथेसिस ने बताया था कि सारे मैग्नेटिक फिनोमिना हम एक्सप्लेन कर सकते हैं किसकी हेल्प से? सर्कुलेटिंग करंट की हेल्प से. एम्पियर सर्कुलर लॉ अगर आपको याद होगा स्टूडेंट्स, एम्पियर सर्कुलर लॉ ने एक्सप्लेन किया था. इट एक्सप्लेन्ड दैट circulating current can explain the entire magnetic phenomena. सिंपल आप इसे याद रख सकते हैं, समझ सकते हैं कि सारा मैग्नेटिक फिनोमिना एम्पियर सर्कुलर लॉ ने एक्सप्लेन किया था. एंड व्हाट इज सोलेनॉइड देन? सोलेनॉइड और बार मैग्नेट ये चीजें कैसे एक जैसी हैं? सोलेनॉइड हमने पढ़ा था पिछले चैप्टर में. इन योर प्रीवियस चैप्टर वी हैव डन सोलेनॉइड, टोरॉइड एक्सेट्रा. द बार मैग्नेट बेसिकली इज इक्विवेलेंट टू सोलेनॉइड. हाउ? बार मैग्नेट कैन बी थॉट ऑफ अ लार्ज नंबर ऑफ सर्कुलेटिंग करंट. बार मैग्नेट को हम मान सकते हैं थॉट ऑफ ए लार्ज नंबर ऑफ सर्कुलेटिंग करंट इन एनालॉजी विद द सोलेनॉइड. स्टूडेंट्स, इफ यू रिमेंबर वन मोर थिंग, हमने मैग्नेटिक डायपोल मूवमेंट की बात की थी. वी हैव टॉक्ड अबाउट द मैग्नेटिक डायपोल मूवमेंट की अगर हम बात करते थे. इफ यू कैन रिकॉल इट, इट इज गिवन बाय m इक्वल टू n अपॉन a. यहाँ n क्या होता था? n इज नंबर ऑफ टर्न्स carrying current I. Number of turns carrying current I, and A होता था आपका एरिया वेक्टर. तो बेसिकली एम्पियर सर्कुलर लॉ ने यही एक्सप्लेन किया था कि जब भी करंट कैरिंग लूप में करंट चल रहा है, दैट इज मैग्नेटिक फील्ड अलोंग द लाइन एलिमेंट इज इक्वल टू म्यू नॉट टाइम्स द करंट. में सर्कुलेशन के कारण, करंट की सर्कुलेशन के कारण ही सारा मैग्नेटिज्म है. यानी सिंपल भाषा में बोलें तो करंट की मूवमेंट के कारण ही मैग्नेटिज्म का बेसिक्स चलता है. ना होता क्या है, जब हम सोलेनॉइड की प्रॉपर्टीज को स्टडी किया अभी हमने यही पाया कि सोलेनॉइड इज एनालॉगस टू योर बार मैग्नेट कंसेंटिंग. अगर हम इसे दो हाफ में कट कर देते हैं, मान लीजिए साउथ नॉर्थ, एंड सिमिलरली इफ वी गो फॉर हम सोलेनॉइड की बात करें, उसे भी हमने कट कर दिया है यहाँ पे. वी फाइंड कि सोलेनॉइड इज शोइंग द सिमिलर प्रॉपर्टी as that of solenoid is showing similar property as that of bar magnet. दोनों की प्रॉपर्टीज एक जैसी हुई. तो बार मैग्नेट और सोलेनॉइड हैज अ ग्रेट रिजेम्बलेंस. इनकी काफी सारी रिजेम्बलेंस एक जैसी है. अब जब हम इसे दो पीसीज में बांट चुके, तो इसका जो फील्ड होगा, मैग्नेटिक फील्ड will definitely be there. Field will be there, but weaker. Magnetic field will be weaker. ये थोड़ा सा weak magnetic field होगा. This is how the solenoid resembles your bar magnet. अब इसे हम प्रूव करेंगे. अगर हम बात करते हैं इसे प्रूव करने की, ये तो था थ्योरेटिकल कॉन्सेप्ट कि सोलेनॉइड जो है बार मैग्नेट की तरह बिहेव करता है. नंबर ऑफ फील्ड लाइंस अगर हम सोलेनॉइड में हम कंपास नीडल से टेस्ट करें तो सोलेनॉइड के पास भी कंपास नीडल वैसे ही बिहेव करेगी जैसे कि बार मैग्नेट के पास करती है. Now let us calculate the magnetic field of a bar magnet at axial point. So students, when point lies on the axial line of bar magnet, यहाँ पे हम एक्सियल लाइन में जहाँ पे जिस पॉइंट की हम बात कर रहे हैं, पॉइंट P, that is considered to be unit north pole. For example, this is your bar magnet. Let's see like that. The south, here, north. Now that point P lies here. This is the unit north pole. इसे हम नाम देंगे unit north pole. यहाँ पे हमने मैग्नेटिक फोर्स स्ट्रेंथ निकालनी है, मैग्नेटिक फोर्स की स्ट्रेंथ निकालनी है by using the Coulomb's law of magnetism, which we have done in previous video. So this is your strength of south side, strength of poles. This small m is the strength of poles. And dipole, अगर हम यहाँ उसका सेंटर मानते हैं dipole का, तो this side length is L, this side length is also. Let from the center of dipole, the distance of this point is R, and this entire, and from here the distance is R plus L, and from north the distance is your R minus L. यहाँ से लेके यहाँ तक का distance is your, this entire thing is R plus L, and from here up to the distance, up to this area, that is your R minus L, and this is your distance R. Now the force north and force experienced by south. So this is the unit north pole. तो यहाँ पे आप देख पा रहे हैं north के कारण जो force लग रही है, that is repulsive force. Here जो south के कारण है, that is your attractive force. Students, look carefully. Here the small m is the strength of either pole into distance of separation. This is basically magnetic movement, magnetic dipole moment, that is m into 2l. Strength of either pole into distance of separation between them. ये क्या था? Strength of either pole into distance of separation between them. We have to remember this. And now let's start. What will the force exerted by north pole? What is the force exerted by north pole? Let's see. This is your distance R minus L. This is your R plus L. This is the distance from the center of dipole, that is R. Now the force exerted by north pole. Now according to Coulomb's law, it is mu naught upon 4 pi strength of poles m into unit pole and divided by distance square. But here the distance in case of north pole is R minus L square along. इसकी direction कहाँ है student? Along n. This is your direction along the n. Now force due to south pole is again mu naught upon 4 pi. Strength same, R plus L whole square, and it is along PS vector. It is along PS. So this is your strength force due to north, and this is force due to south. So net force will be your given by, the net force will be given by, it's very interesting, it's just like your electric field में जब हमने dipoles की बात की थी, axial line, external line, all that, it's just same, but here we are just doing these things with related to magnetic field. Now the net force is given by Fn minus Fs. that is your mu naught m upon 4 pi. It comes out to be 1 upon r minus l square, and that comes out to be minus 1 upon r plus l whole square. It comes out to be mu naught m upon 4 pi r square minus l square whole square. It comes to be r plus l whole square, r minus l whole square. On solving, let's see, on solving we'll get, हम इसे solve करेंगे further. The answer, let's see what will the answer. Now here the answer will be, the net force will be mu naught upon m 4 pi. It comes out to be r square plus l square plus 2rl minus r square plus l square minus 2rl, and now this is same, r square minus l square whole square. So next step, students, I think these steps are very much clear to you. This is due to your north and this force is due to your south pole. Mu naught upon m 4 pi common, and we are left with these things. That is your r plus l whole square minus r minus l whole square. These are the results. Now further I am writing here. Just note it down very carefully, students. Now the next step is, it's very simple one. Force is equal to mu naught m 4 pi r square plus l square plus 2rl minus r square minus l square plus 2rl, and here now comes out to be r square minus l square square. Now r square get cancelled, l square get cancelled, so we are left with mu naught m 4 pi, that is your 2rl upon r square minus l square whole square. Now this comes out to be your 4rl, sorry, not 2rl, 2 plus 2, that is 4rl. Now mu naught upon m 4 pi. Now this is your 2r into 2l upon r square minus l square square. अब why I am writing 4rl को मैं 2r into 2l क्यों लिख रहा हूँ? There is a reason behind it, and that reason will be very much clear to you just now. We know magnetic moment, dipole moment is m into 2l, yani strength of either pole into distance of reflection. So this factor m into 2l is there. You can write mu naught upon 4 pi. In place of m into 2l, we will write now capital M, r square minus l square whole square. Now students, now what we'll do, for a short dipole where l is less than r, we are left with the last, that is the expression reduces to mu naught upon 4 pi, mu naught upon 4 pi 2m upon r cube, 2m upon r cube. Let me write full. For l less than r, it will be now r square whole square. It comes out to be mu naught upon 4 pi 2m r power 4. Now it comes out to be mu naught upon 4 pi 2m r cube. B axial, that is net force experienced. Here B axial is net force experienced by north pole, experienced by north pole at point P. And expression, students, it is given by, so finally it is mu naught upon 4 pi 2m upon r cube. So magnetic field strength due to axial line is this. Now when we move further for a solenoid, we get the same results. Axial field of finite solenoid, axial field of finite solenoid carrying current. You can see a solenoid over here. A is the radius of the solenoid and 2L is the length of the entire solenoid. Here O points toward the center of solenoid, I is the current flowing through number of turns of the solenoid, and P is the point where we have to calculate the magnetic field generated due to solenoid, magnetic field produced due to solenoid. Let us consider dx a small element. here the number of turns is n and dx, current carrying element, we have considered this dx. Now from center to this element dx, the distance is x, and from center of solenoid up to point P where we have to find magnetic field, distance is r. So students, we can write now, from this information we can write A is the radius of solenoid, यहाँ पे A है radius of solenoid, 2L is length of the solenoid, पूरे solenoid की जो length है that is comes out to be 2L, length of solenoid with center O, and N is equal to number of turns per unit length, number of turns per unit length of what? Per unit length of solenoid. Length of solenoid. I is the current passing through the solenoid. I is the current. You can simply write I is the current passing through solenoid. I is the current passing through the solenoid. Number of turns in this element dx. हमने current element consider किया यहाँ पे, that is dx. So number of turns in the element dx is given by n dx. Number of turns in the element is n dx. So now the magnetic field P due to the current carrying element, magnetic field P निकालना है, magnetic field B due to current carrying element at point P, magnetic field B at point P due to current carrying element. I am saying here we have to find magnetic field due to dx, that is current carrying element at point P. At point P. Here is the point P, students. This is your point P. Here at point P we have to calculate the magnetic field, that is dV is equal to, now here, mu naught Ni A square. This is your mu naught Ni A square n dx divided by 2 r square, r minus x whole square plus A square par 3 by 2. This is the magnetic field which is, we have done this equation in our previous chapter. If you remember, the small current element dV, then it is given, magnetic field dV is given due to this element, that is mu naught Ni A square n dx to twice r minus x square plus A square 3 by 2. But if P lies at far distance, अगर point P, this is point P, lies at large distance from O, then if P lies at a large distance from this point O, then R greater than A, then also R greater than X. So we can get then students, R minus X square plus A square, that is your R minus X square plus A square power 3 by 2 is reduced to your R cube. So now the equation becomes, अब equation क्या बन जाएगी? Now the equation becomes dV equal to mu naught I A square upon 2R cube and nd. This is your magnetic field now reduced to this value. Now considering the all elements from minus L to plus L, x के सारे elements को अगर हम consider करते हैं from minus L to plus L, then by integrating this equation we get, now we can integrate this equation. You can see this diagram now. Now there you can just, now we can write simply by integrating. Integration से क्या आएगा हमारे पास, b is equal to mu naught I A square. N is also there, you can write Ni A square. Simply you can write mu naught Ni A square. Mu naught Ni A square. Then it is your 2r cube, and this is dx is integrated from minus L to plus L. dx की इंटीग्रेशन क्या होती है स्टूडेंट? dx is integrated to x only, mu naught Ni A square 2r cube. This is integrated to x minus L to plus L. Now upper limit minus lower limit. Now we'll go for upper limit minus lower limit. That comes out to be mu naught Ni A square 2r cube. Then this comes out to be L minus L, that is your mu naught Ni A square 2r cube. Then this comes out to be your 2L. Mu naught Ni square 2r cube into 2L. Now further we can write it in a more simplified manner, that is equal to the next step. The next step, students, observe it very carefully. Now from here the equation reduced to dv equal to mu naught upon 4 pi. You can write it mu naught upon 4 pi 2n into 2l, 2n, it's clear, 2n into 2l, and now r cube Ia square, that is your Ia square. Students, now this 2n into 2l, there is a purpose for writing this. You know, magnetic moment is given by, that is your total number of turns into current, total number of turns into current into area of cross section, area of cross section, area of cross section. Now this comes out to be, now we'll further move. Now the equation becomes total number of turns, that is your n into 2l into current, n into 12 total number of current, n into 2l is number of turns, sorry, I is current, and your area of cross section is A square, divided by r cube. Obviously 2 is there, so it comes out to be, that is mu naught upon 4 pi. Let me write once more, mu naught upon 4 pi. Now student, this entire things comes out to be m. That is n into 2l into I into A square is your m magnetic moment. It comes to m upon r cube mu naught upon 4 pi. Here you can write m किसके बराबर है? M is equal to, here your m comes out to be n into 2l into I into A square. So this is the same equation which we have obtained the magnetic field strength in case of bar magnet. Similar it is obtained in case of solenoid. तो हम कह सकते हैं बार मैग्नेट इज इक्वलेंट टू सोलेनॉइड. ये हमने प्रैक्टिकली भी प्रूव कर दिया, एंड फॉर केस ऑफ बार मैग्नेट एज वेल एज फॉर द केस ऑफ सोलेनॉइड.